Okay, sorry about that. Someone at the door, so I had to rush out and have a look at the door. I think we're done the thinking distance. So we said multiply these two together, the 30 and the 0.7, and we got 21 meters. And then this one, we can see we've got a change there. So we said that was the thinking distance. So we're now going to do the braking distance. So that's a change of 30, that's a change of 2, and then we've got to divide it by 2 because it's a triangle, because we know that's length width over 2. So 30 times 2 divided by 2 equals 30. The total stopping distance is those two things added together. So 21 plus 30 equals 51. So remember, we know stopping distance equals thinking distance plus braking distance. And then, for example, if we wanted to work out thinking distance, we can see we just got a minus braking distance from each side. So that'd be stopping distance minus braking distance, if we have to do that. Okay, two factors that reduce braking distance. That's definitely a good thing. So if we had a road, and then we'll have Macy over there. There's Mr. Rayside in his battle tank. And clearly, the shorter the distance, the better, because then there's more chance of us stopping. So a smaller braking distance, we're going to stop sooner, and therefore I'm not going to kill Macy. So anything that will reduce the kinetic energy, and we know that's half mv squared, or anything that will improve the braking distance. So reducing the kinetic energy or improving the braking efficiency. So any two of these, and just pick two that you like. So reduce some speed, reduce the mass of the vehicle. That really should have a reduce. There we go, put a little arrow in there. Some good quality brakes or tyres, a dry road, or a greater braking force. So the next one, it says describe the graph, use the graph to describe how the speed changes. So no maths, just got to say what's going on. So if it's curving upwards, it's accelerating. Remember to always check this bit first. All right, so it's accelerating in A, constant speed at B, it's decelerating at C, and at D it's stationary. Next part, terminal velocity and weight. So a student wants to investigate how the area of a parachute, so we're going to have to make some different areas. So equal parachute, next size, and so on, making it increasing. And it says describe a method that could be used to get some reliable and accurate results. So the first one is we need to drop it from a decent height. That'll make it accurate. And reliable, we need at least 5 parachutes, all right, to investigate the area. So here we go. Choose at least 5 parachute areas. So I've picked an example there, 10, 20, 30, 40, 50 centimeters squared. That's going to work beautifully. Drop from the same height. And then please remember to always include the equipment using a ruler. Measure the time with the stop clock. There's my equipment. So measure the time of the fall with the stop clock. And then the last part is use your words. Speed equals distance divided by time, because it wants the falling time. Now, I could have put in there, drop from the same height, and I could say as large as possible, really. I will go with 2 meters, so that will reduce the human reaction times, as that's a source of error. On to the last bits, weight as a mass. So the weight has a mass of 0.6 kilograms. What is the overall weight? So we're going to need the my wrinkly gram, and it wants weight, easy. Multiply the two together, and remember gravity is 10. So 0.6 times 10 equals 0.6 newtons, because weight is a force. So if you're on a planet and you're standing on the planet is pulling on you. Equally, you're pulling on the planet a little bit as well, with this equal and opposite force. And it says, what's the acceleration on a parachute when it reaches terminal velocity? So we know at terminal velocity, that's your maximum falling speed, the forces are balanced. So we know that the force of air resistance equals the force of weight. So weight equals air resistance. Those two will cancel out. So the resultant force is 0, and therefore the acceleration is 0 meters per second squared. And there you go. That's the video for this. So good luck with your test on Thursday.